Hello and welcome to the Field Guides. I'm Daniel and I'm here with Steve and Bill. Good morning, guys. How we doing?
Morning, Daniel.
Morning. And what we're going to do today is do part 2 of our Timber Rattlesnake episode. So if you haven't listened to part 1, go back and do that because we're not going to do the whole intro.
All right, well done, Daniel.
Slacking off on his second episode.
Hey,
wow.
Baby steps, guys. Baby steps.
His first intro.
Yeah.
Well done, sir.
Although that was okay. I think I said once in there.
That's right.
Although, in defense of Dan, we've done roughly the same number of episodes since his first episode, probably.
Not too many.
If I did more, not too many more. So.
All right, so folks, welcome back to part 2. We're going to continue talking about timber rattlesnakes. And we are at the same site. We are still at Mossy Point. We're actually heading out close to the point, working our way through the snowy woods. But right now, let's talk about feeding, what timber rattlesnakes eat. So their prey are mostly small mammals, and it may include small birds, frogs, and other snakes. They can eat other rattlers, but the most common snake they do eat is the garter. Now, like most rattlesnakes, timbers are known to use chemical cues to find sites to ambush their prey. This is an ambush predator. They often rely on fallen trees to locate prey. Fallen trees, they tend to act as travel corridors, basking platforms too, for many small animals. In what's become known as the Reinert position, timber rattlesnakes tend to curl up along fallen trees with a portion of their body and lower jaw touching the log. This allows them to feel for vibration. And they hunt almost entirely terrestrially on the ground. So prey that's up in the trees, like squirrels, they're caught when they come down to the ground. So it has been noted that when prey is in the tree, the snake might assume a vertical tree posture, meaning that it leans up against a tree, looking at the squirrel and waiting for it to come down.
Whoa.
So you got to wonder if the squirrel notices it and is like, oh, and then makes its way to another tree.
The smart ones do it. In the
All right.
study that I found, that position that you described was referred to as the log posture.
The Reinert.
Reinert?
Yeah,
Oh,
yeah,
okay.
they were just calling it, the log-oriented posture.
Okay. And I couldn't find who Reinert was. So now we're going to quiz you guys a little bit here because I did find one study that did a breakdown of timber rattlesnake prey by genera.
Okay.
All right. So
Oh boy.
the thing they ate
What type of
most,
quiz is this?
the thing they ate most, at least in this group that they studied, 33% of the prey
Mus.
was was from Peromyscus.
Pero.
Deer mice.
Very good.
Whoa, good
Very
job.
good. So it's mostly deer mice. About 11% was Microtus.
It also sounds like another mouse, but I have no idea what
We
it is.
mentioned them already. Voles. Very
Oh,
good, Daniel.
whoa.
All right. All right, Steve, come on.
I'm not,
You're
I've
0 for
lost.
2 here.
Yeah.
Tamius.
I actually know Tamius, but I
10% of their prey. Tamius. Daniel?
Squirrels?
Close. Well, yes and no. Chipmunks.
oh, chipmunks,
So,
cool.
ground squirrels. Next
I must
one.
confess, though, because I'm a man of integrity.
Yes.
I did find a study about their eating, and they had those terms.
Good
and
for
I had to
you.
look into it, yeah, because I'm like, what are these long words that I can't say? So
Way to
this
be
wasn't a
honest.
fair quiz.
No,
against
this
Steve.
is like what I'm quizzing Bill on carnivorous plant genera. So this is fair.
All right, next one, another 10%. I want Steve to get this one. And I'll pronounce it probably the wrong way, but to help you.
Okay.
Silvalagus. Or lagus.
Oh, lagus? It must be some type of rabbit or hare. Or something.
Lagomorph, right? Yep. So those are rabbits, cottontails. And then this
See,
one,
when you spoon feed me, it's easy.
this is one I did not know. 5% is Sigmodon.
I don't know Sigmodon.
Sigmodon. This was
Sounds like an extinct species, some kind of dinosaur.
this was cotton rats.
Cotton rats.
Yep. And then Sciurus, squirrels.
Okay.
That was 4%. Several birds also showed up, but they're always secondary to mammals in
Okay.
terms of what they're eating. But and they're chiefly ground-dwelling bird species like bobwhites.
I was going to say, how often are they getting the birds over the
Exactly.
eggs?
Well, they said there was
I
a
wonder.
surprising number of passerids. So, and this was in this study. This was typically not eggs. This was, actual adult, or at least not egg birds. All right, now we're going to get to what Daniel has been researching for us. So we'll be sharing this next part together. We're going to talk about their bite and their venom. So why don't we talk about their teeth first? Because there was a long section in here that part of me kept wanting to leave out, but I just couldn't leave it out because I found it too interesting. And we've mentioned this briefly, the different dentition in snakes. So in part 1, we talked about how different species have different modes of reproducing in terms of do they lay eggs or do they have live young. So we're going to talk about their teeth, and different species have different dentition.
Right, so the way I pictured it is
Yeah.
you said non-venomous snakes, they had a full set of pearly whites just like humans. And that's why
That would be so creepy.
Oh man.
I'm sure there's photoshopped or AI
Sure.
images online
Thanks
now.
for the pending nightmare, Steve.
No, they just have one big tooth that goes all the way across.
Is that serious?
No.
Oh, I'm like, that would be insane if that was true. Like how
So all snakes have backwards facing teeth that help them to secure their prey and prevent it from escaping. This is called a glyphos dentition. Snakes described as having only a glyphos dentition don't have fangs for the delivery of venom, and they're almost entirely non-venomous. So this includes boas, rat snakes, bull snakes, and North American king snakes. There's 3 additional types of dentition, all of which include different types of fangs. So that's what we're going to get into now. So there's some long words in here. I'm not going to dwell on them for too long because I don't expect anyone to remember them. I don't remember them.
I already forgot the name of the one you just said.
A glyphos.
A glyphos,
Yep.
okay.
So those are just the backwards facing teeth that all snakes have. So there's solenoglyphous dentition. These are snakes with teeth and then big fangs. Typically 2 large fangs on their upper mandible. That's found on all viper species, including the rattlesnakes.
I wonder if the root of that word it comes from the same root as solanum, like the potato and tomato genus. Because those are
potato
also
and potato or tomato.
the potato and the potato genus, yeah.
Now you're talking my language.
But the reason I bring that up is because solenum it's known for being poisonous, right? Or not every species, obviously, because we eat tomatoes and potatoes and stuff.
Yeah.
I wonder if there's some kind of connection.
Right. And I'm frantically trying to think in my brain, I must have looked up what these words meant, but for some reason it's not in my notes. So I don't know. And folks, I was telling the guys before we were recording, just diving down this rabbit hole of timber rattlesnakes, there's just so much information. I really, really tried to make this a 1-part episode, and I just couldn't. There was no way to do it. I kept going through all my notes and being left with like 6 pages of notes. I just couldn't do it. All right, so these fanged ones with the 2 big fangs, which our timber rattlesnake has, they have sharp hollow fangs for the injection of venom. Think of like a hypodermic needle. The fangs are hinged, so when the mouth is closed, the fangs lay flat parallel to their upper jaw. But when the snake strikes, those fangs swing down into more of a perpendicular orientation. The venom glands are well developed. So venom is delivered to the fangs through a duct. Once the snake strikes and closes its jaws, compressor muscles deliver venom at high pressure. So it's really injecting the venom. Now another tooth type, these are proteroglyphous, belong to snakes with smaller, non-hinged fangs on their upper front jaws. So these include cobras, coral snakes, mambas, and sea snakes. Sneeze snakes. That's from Dr. Seuss. These fangs are about 3 times shorter than solenoglyphous fangs. And as I'm talking, I'm thinking I'll probably put some pictures of each of these onto the episode notes.
And are these also hollow?
So hang on.
Oh, yeah.
While most solenoglyphous snakes strike their prey, release, and then hunt down their injured prey, so that's that first group. So when timber rattlesnakes, they'll often strike, inject their venom, and then basically just hang back and wait for it to die, more or less, or succumb. These guys, the proteroglyphous, they'll simply strike and hang on and wait for the venom to take effect. And some of these species will even envenomate and constrict. So trying to hold on and really to stop blood flow through the animal. So Steve, you just asked if they're hollow. I don't know. We'll have to put that into the episode.
But if it's venomous, I would imagine it would have to have a injection
It is connected
system.
to a venom gland. Okay, so I would imagine that they are hollow, but I don't want to say for sure. We'll put that into the notes. So the last group,
Really quick, I want to go back. So we talked about 3 groups so far.
we talked
right?
about 2 groups so far.
Wait.
So all snakes are a glyphos. They all have a number of backward-facing teeth that hold on to their prey.
Understand.
So now
Yeah.
these three groups are snakes that have some kind of venom. So the first group, like the timber, they have those big fangs that are hinged.
Got it.
The second group that I just mentioned, which includes the coral snakes and cobras, those fangs are not hinged, they're shorter, but they are still delivering venom.
And you said those are snakes that usually hang on to their prey.
They
a little
hang
longer?
on to their
No,
prey.
I was wondering, when you were describing that to me, it was making me think of coral snakes, because I know that their venom is more neurotoxic, so it incapacitate the prey faster.
Right.
Which, you just
Makes
hang
sense.
on to it until the venom incapacitates the prey. So I'm glad.
going
you said
soon.
that. Yeah.
So this last group, they're called Opistoglyphous snakes. Their fangs are in the back of their mouths. They're small fangs, and they're simply grooved. They don't have a venom gland, so they're not hollow. Species like this, such as the eastern hog-nosed snake and garter snakes, instead have something called a Duvernoy's gland, which appears to be similar to a parotoid gland in toads. It releases mild venom passively. So again, these are Opistoglyphous snakes. They gnaw on their prey, and it's thought that maybe the grooves in their rear fangs help guide the toxin into the bite. The more they chew, the more venom is delivered to their prey. Garter snakes were long thought to be non-venomous, but this was just discovered in the early 2000s. So like within the last 20 years, that they in fact secrete a mild neurotoxic venom from their Duvernoy's gland.
Well, it must be very mild though, because I've known. Well, I haven't been bit by them, but I've known people that have been bit by garter snakes, and usually it's just like a red, inflamed a little bit, but
Yeah.
it was very mild, incredibly mild.
So they, and as you said, they can't seriously injure or kill anyone. The venom is comparatively mild. But in a few cases, some people experience swelling and bruising. But timber rattlesnakes, they are again solenoglyphous. So they have those big fangs, and they also have a high venom yield. And that makes them potentially one of North America's most dangerous snakes. But it's offset somewhat by what we said at the beginning of part one. It's offset somewhat by their mild disposition. And usually before striking, they often perform a good deal of preliminary rattling and fainting. So just like they're gonna bite. They also have a long brumation period in a lot of their range. So like up here in New York, you're not gonna see timber rattlesnakes, or even in Pennsylvania really, where they're more common, from October to April.
Yeah.
Like that's typically their brumation, which is what, 6-7 months, right? Now, let's get into the venom, because one thing that I didn't know, and one thing that really started us on this path of exploring timbers for this episode, was finding out that there's considerable geographic variation in the toxicity of the venom of timber rattlesnakes. Now, I found in my research, Daniel, that happens in a lot of rattlesnake species. I didn't realize that.
Yeah, there's tremendous variation in the venom. And the papers that I were reading were talking about the reasoning they think behind that is because of how much of a selective pressure the venom is, because that's the primary way they not only capture their prey, but also defend themselves. So selective pressures are going to be pretty strong, and that's going to cause evolutionary changes to happen quickly.
So when you guys are talking about variation, you're not talking about daily variation, like time of the year variation. You're talking about like from group to group or individual snake to individual snake. There's
Right. Like a snake here in New York State may have a venom that acts very differently from a snake in Florida, a timber rattlesnake in Florida.
Yes.
Same species, but I mean, sometimes, correct me if I'm wrong, Daniel, some can be neurotoxic and some can be hemo, like affecting the blood more.
Yeah, like a necrotic. Yeah,
Right.
so it causes like apoptosis, which is cell decay, hemorrhaging, it prevents blood from clotting.
Right.
So what I learned when I moved down to Okefenokee was, one, that people have a lot of interest in venomous snakes, because of the potential dangers and such, and they are a polarizing figure. That's probably why there's so many studies on them. But people in a lot of my programs would constantly ask about the venomous snakes of Okefenokee. So I would read about them, and essentially the simplified results that I found regarding the venom was the 3 rattlesnake species possess more of this necrotic venom. So this venom that causes hemorrhaging, cell death, prevents blood from clotting, that sort of thing. In reality, that is a gross oversimplification. There's a lot of variation between different venom types, not only between different populations, but venom types can also change within an individual over its lifetime.
Whoa.
Which is pretty crazy.
I didn't come across that.
Yeah.
Whoa.
To me, just you saying that almost makes more sense, because it's hard to believe that the venoms would act so differently in different populations or in different individuals, unless either those venom types were either so similar to each other in the first place, or the same snake could do, like, depending on its development or whatever, I don't know, like that it could potentially create both.
And to me, it seems to make more sense that there might be some variation geographically. Maybe that has to do with prey, in those different areas. But in terms of an individual, why would an individual need to change? Like, as you get older, do you have to switch to different prey that,
And maybe you guys have something on this, but I would have to imagine the venom is probably a mixture of many different proteins. And you could imagine that certain might be upregulated in some populations, and some are downregulated, and that could end up giving a totally different venom effect.
The study that I found talked about how a lot of the venom components was due to gene expression. So they had the gene sequences to be able to technically create similar types of venom from other snakes, but it's about which genes were expressed. So that can attribute to the immense variability. That's one of the reasons why.
So I wonder if that expression, like these genes turning on and off, is that environmental?
That they said was unknown. They don't know what the environmental cues are, if it's a prey thing. They don't know what causes that change, in an individual or within populations in a way.
Cool.
They talked about the pros and cons of certain venom types, so I can get into that.
Yeah.
The one paper that I found, they were talking about rattlesnakes in particular, and they mentioned some other studies into rattlesnake venoms. And they essentially, based on another study, broke the venoms down into two types. So that type 1 venom is more of that necrotic venom. So it results in breaking down of the capillary basement membranes, local and systemic hemorrhaging.
So hang on one sec. So just to explain that a little more basic for the audience, because I was looking this up last night. I read those exact words and I'm like, what the hell does that mean?
Like cell membrane breakdown. Yeah, that's what I think what you'd mean by necrotic, because you're breaking cells down. And
yes.
But the part about where you talked about the capillary walls, that's basically your blood vessels are breaking down, causing massive internal bleeding.
Yes.
Yeah. So it's
horrifying.
bad news. Yeah. It's horrifying.
Not great. So this is more associated with that type 1 venom. The type 2 venom was different, and it tended to be more lethal and neurotoxic. So according to what I originally learned down in Okefenokee was the type 1 venoms are what's found in rattlesnakes with a degree of variability.
And this type 1 and 2, you're talking about rattlesnakes in general, right?
Yes. So these two types are used to classify rattlesnake venoms.
Okay.
Yeah. They didn't mention anything about other species or so.
Okay.
So usually, and this goes along with what I originally learned, rattlesnakes do possess type 1 venoms. Of course, there's always degrees of variation, but in the previous study that they mentioned, 20 out of 26 rattlesnake taxa examined revealed type 1 venoms. So it did appear that was the more common venom amongst rattlesnakes.
And how many out of 26?
20.
Okay.
Yeah, so a little bit more than 2/3. Now, the cool part was that they analyzed then an eastern diamondback and then the canebrake rattlesnake. So when I say canebrake, I'm referring to the southeastern coastal populations of timber rattlesnakes. That's what they're called down there. They analyzed these two because although they do have slight preference differences in habitats, they are found occurring in the same places. They're roughly similar sizes, and they usually go after similar prey. So it would make sense that their venom would be somewhat similar. But what they had found was they mentioned that in a previous study, an extremely lethal neurotoxin was extracted from a timber rattlesnake in North Florida. So then you would refer to that as a canebrake rattlesnake. So they referred to that toxin that they pulled out as the canebrake toxin.
I came across that too. Yep.
The canebrake toxin. So what this study did was it really wanted to dive into, at the molecular level, the toxins. So they collected an eastern diamondback rattlesnake and a canebrake rattlesnake, and then from North Florida, and they examined the toxins. And what they had found was that in that eastern diamondback had all the proteins and such and stuff that was way over my head that made it fall underneath that type 1 category. And then they found all the proteins and such that would have made that venom more neurotoxic under the type 2 category in the canebrake rattlesnake. So that was interesting there, because the question is, why? Why is it this southeastern population? Because they had mentioned that in most populations of the eastern diamondbacks and then most populations of timbers, they have type 1 venom. But when you get to these certain populations in the southeast, you'll start to find the type 2 venom in the canebrakes.
But they don't know why.
They're not sure why.
Wow.
Yeah. So part of this is a thought that I had with absolutely no scientific backing behind it. They mentioned that type 1 venoms, being necrotic, do assist with the digestion of prey, because it's already starting to break down. So they mentioned that the type 2 venom, while it is in theory more lethal because it's neurotoxic, it incapacitates your prey better, it does not assist with any of the breaking down or digestion of prey. So in colder environments, potentially, that might be more of a setback because a certain body temperature, thermal regulation, needs to be achieved in order for digestion within cold-blooded animals.
So these snakes down south, they don't need that
Because
little
it's
boost
warmer,
to help
they
digest.
might not, they probably don't have as hard of a time achieving the body temperature necessary to digest without the addition of a necrotic venom.
But there's no research.
Absolutely nothing.
Okay.
I just thought that, yeah.
I like it though.
Because then you would also have to wonder why other populations in that area aren't also,
Exactly.
even if it's by mistake, I guess all evolution is sort of like a mistake. I don't know.
It's random.
But yeah.
To a degree.
Why you wouldn't see it popped up, or maybe it is popped up. We just haven't maybe surveyed all the populations or something. I don't know.
And you would think if that was the case, the eastern diamondback that they sampled for venom as well, that would also have more of this neurotoxic venom to it. But
Right.
it's found in the canebrake, not the eastern diamondback, which is so interesting.
My
And
brain's generating so many questions.
it was cool to follow up on this because I was actually at my swamp mentor down south, Chip Campbell. I was helping him do some work on his house, and we came across a pygmy rattlesnake, like right next to his house. And we were just talking about rattlesnakes and the different venoms and such, and I had brought up how rattlesnake venom is necrotic, and he said, usually, but a lot of some of the canebrakes in the southeast, some of these populations have more of a neurotoxic component to it. So he was the first one that told me about that, and kind of was the first clue to just how complex the venom is. I mean, even just within that type 1 and that type 2, there's just immense variation in the venom. Yeah, which is interesting.
We've said that neurotoxic venom is more deadly, but so how is it killing differently? So I know before you explained the necrotic one is it breaks down cells, there's more bleeding internally and things like that. What is the mechanism for killing for a neurotoxic venom?
Paralysis is a big part of it. So they mentioned a certain protein that would paralyze back legs. So paralysis, but also too, paralyzing essential functions like your lungs and such. So
Got it.
yeah.
Because remember, in case the listeners aren't sure, neurotoxic, that's going to affect your central nervous system.
Yes.
So including
Got
your
it.
brain, all of those. And that pretty much is running your body. So
Yeah. So the venom, it enters in one area and then
spreads.
Well, I'm sure it probably spreads generally, but it affects the nervous system.
Yeah. And think
specifically.
about it
Yeah.
too, like if you're paralyzed, like the snake doesn't care if you're still alive, right? It's,
Yeah, no.
it's going to start eating you if you're
Yeah.
partially paralyzed, which is horribly terrifying.
It is terrifying. But yeah, we had learned that mostly rattlesnakes have this necrotic, coral snakes have a neurotoxin, but it's funny, the biggest example of rattlesnakes having this neurotoxin within these two species are ones down south, where that's where I was learning about them. They did mention a bunch of other types of rattlesnakes in different genuses possessing this really deadly neurotoxin that was similar to the canebrake toxin. And one of the things that they were talking about was it would seem that the type 2 venom would be advantageous because it has a greater ability to incapacitate prey, which was slightly odd to them considering the type 1 venom, as we mentioned, was more common amongst rattlesnake species. So that was one of the questions that they had. So this stuff started to get over my head a little bit, but when they started to go down into the the genome sequences and the toxin sequences, the diamondback's toxin had 123 unique toxin sequences that fell into 78 clusters. So these are what determines the outcome of the venom. The canebrake had 61 unique toxin sequences and 53 clusters. So this led them to a potential hypothesis as to why type 1 may be more beneficial. And they thought that the type 1 may be beneficial due to higher survival probability by means of functional redundancy or mutational robustness, meaning that it has the greater ability to adapt to changing environments because there's more protein sequences that make up that venom. Versus the canebrake toxin is a little bit more specialized. It doesn't have the greater ability to adapt.
Now, when you say in clusters, I wonder if that means that they're situated right near each other on the genome, because sometimes that's how genes are expressed. So let's say if there's a group of proteins that work together for some function, sometimes they'll be in like a cluster. So when the one's expressed, that RNA polymerase only has to it just sequences a whole chunk of genes together
with its
right?
neighbors.
Yeah. So when they're grouped together on the genome, they're more likely to be expressed together on the genome. So maybe that's what they mean by clusters, because we've seen that in other, like in plants and stuff.
We're gonna go with that.
Yeah.
So they're saying that maybe a longer-term evolutionary advantage would lie within the type 1 because of the greater ability to adapt and mutate to different circumstances, and that the type 2 venom has more of a short-term fitness advantage.
And that would seem to make more sense because type 1 is much broader in the populations, right?
Yes.
In the range. Like you're going to find type 1 much more commonly.
Because the question that they're posing was, why is type 2 not more common if it has a greater ability to incapacitate prey? And that's one of the theories that they come up with, which does make sense.
They're weird in Florida.
Which does make sense. Yeah, everything's just got to be a little bit different down in Florida.
That's right.
Yeah, and you had mentioned gene redundancy or protein redundancy.
Yeah, if you want to hop into that.
So it is a topic in genomics where you talked about adaptation. So when you have this is the easiest example that I can think of. So let's say you have a whole genome, and let's just imagine that every gene in that genome is necessary. So you can't afford to have a mutation in any gene, because this isn't true, but let's just say that every gene in this hypothetical genome is absolutely necessary, can't afford to have mutations or anything. If you have something, like in plants, it's much more common than in animals, but if you have something called a whole genome duplication, suddenly you have 2 copies of all of those essential genes, meaning that every gene has a redundant copy that can build up mutations, and potentially, for the most of the time, those mutations are going to make the gene non-functional, so it'll never become a useful protein at all. But there's always the chance that it mutates into something new. That's a super rare thing, but it happens. Or there's maybe both copies build up mutations, and so now they both kind of do the same function, but they can tweak the expression of those genes a little bit more carefully.
Okay.
So that's called it's most of the time you get non-functionalization when there's gene copies, but sometimes you'll get subfunctionalization. That's when both are retained, but they have they've both accumulated mutations. And then there's the neo-functionalization, which is when something brand new happens, and that's super rare. So.
And Daniel, when you're editing, you can cut that all out.
No, but I think I follow.
No, but I'm saying that's why redundancy is something that is a big topic in genomics.
All right.
Yeah, and it then gone on to talk about how snakes would have gene transcripts for different toxins that they just didn't express, so it wasn't showed through their venom. So like genes for type 1 venoms were found in these canebrake rattlesnakes that, however, ended up exuding the type 2 venom. Yeah. So it sounds like there's different venom potentials that are within the snakes themselves. And because the venom genes are only expressed through the venom glands, there's more freedom with changing in gene expression versus like something that isn't exclusive to one aspect of your body. Right. If you do express it, it could have secondary consequences in some other form or process of your body.
Right.
Versus with these venom sequences, any changes that occurs in that is just going to affect the venom gland and what's coming out of that. So it gives them more freedom with being able to change how they express it, and that's one of the reasons for the great variability, which I just thought was fascinating.
That's so cool.
Yeah, I didn't know it was this complex.
Yeah.
Now, did you come across variations within timber rattlesnake venom? Like geographically, just talking about timber rattlesnakes, and geographically across their range, the different venoms you could find.
I did not come across that.
All right,
yeah. So under what it would say here, would assume that this type 1 type of a venom would be found in the timber rattlesnakes, the more northern species. But remember, within one type, there's going to be tremendous variation that way. Yeah.
So this takes it another step further. So within timber rattlesnakes, they say there's 4 venom patterns. There's A and B, which I'm thinking type 1, type 2, but then there's A plus B and C. So type A, which seems like type 1, is largely neurotoxic. Or no. This would be
so type A would be type 2 neurotoxic. I looked at this similar stuff too, and I was like, oh man, getting the letters.
So let's not worry about
confused.
type 1 and type 2 right now.
So
just for timber rattlesnakes, type A is largely neurotoxic. So again, that acts on the nervous system. It's found in various parts of the southern range, which meets with what you were just saying.
Yes.
Type B is hemorrhagic or necrotic, like you'd say, breaks down blood vessels, causes internal bleeding. I also found it was proteolytic. It breaks down muscle tissue. That's the necrotic. Breaks down muscle tissue around the bite site as well as vessel wall. So it starts that process, accelerating the death of the prey and potentially helping with digestion. So we're matching up here. It's found consistently in the north and in parts of the south. Type A and B is found in areas where the two types intergrade. That's in southwestern Arkansas and northern Louisiana.
That was interesting to me because in the paper, I think we're talking about the same paper here. In the beginning, they're mentioning how it's difficult for a type 1 and a type 2 venom to occur simultaneously, something about their proteins. So the type A and B is just that. It's this hemorrhaging and neurotoxic venom that's found together. So it's an exception to that generalization they stated at the beginning of the paper.
The last type, type C, was described as being one of the weakest venoms that the researchers had explored with a low LD50 in a lab setting. Steve, what is an LD50? Do you remember?
I don't know what an LD.
I had no idea what
an
that was.
So LD50 is the lethal dose. So what is the minimum lethal dose in half a population? Okay, so they like in lab mice. What's the minimum you have to give for half the population to die?
Gotcha.
So it has a low LD50 in a lab setting, lacking both the canebrake toxin as well as the peptides that make type B potent. This venom type was found in Georgia, Florida, and South Carolina, and it's unknown why this variation in venom exists in the timber rattlesnake, though there have been similar studies I found in the Mojave rattlesnake, and those studies suggest that variation is in diet is the driving force, so that it has something to do with what they're eating. So that
certainly makes sense.
It's still an active area of research. Cool stuff. All right, now, anything else about the venom?
No, that's pretty much what I found about the venom.
So I did look into how many people do die from snake bites, because you hear about rattlesnakes, people instantly get worried about being bitten and dying. In the U.S., approximately 9,000 people per year suffer a snake bite.
How many?
Okay. 9,000.
9,000?
A venomous snake bite.
You know what? It doesn't say.
It's probably, probably just a snake bite, if I had to guess.
But only 5 deaths occur. Over 50% of the snake bites that occur in the U.S. are from rattlesnakes. The mortality rate is higher with rattlesnake bites compared to other snake bites, but it is still relatively low. So this is from Poison Center data.
Hold on. So out of all the people bitten, all 9,000 people bitten in the U.S.,
yes,
only 5 died?
Only 5 died.
But that's not saying only 5 out of the venomous snakes.
This is on average, correct.
Okay.
So there was one study of Poison Center data from 1983 to 2007. So about 24 years. Showed 1 death per 736 patients that came into a hospital with rattlesnake bites. Okay, 1 death per 736 patients. And this I couldn't find more information on. The paper said oftentimes the victim of a rattlesnake bite is a young, intoxicated male.
I was just about to say that. On their dominant hand.
I was going to say, is it
Hold
usually
my
on their
beer.
forearm?
Yeah,
that's true.
Yeah, that's what Chip told me.
Watch this.
I believe it.
Yeah.
But you know what? I guess I'm not super surprised that our numbers, the human deaths aren't very high, because we're not their prey. You know, we're the thing they're trying to not have anything to do with.
Right.
So
they don't want to bite us because they're not going to be able to eat us.
If we were a mouse to them.
Right.
One of the analogies I use for that is like if you had to fight a bear, and you would not want to fight it with, a venomous stick or something like that. It wouldn't work. Right. Yeah, you might envenomate it, but then you're going to die. You'd want to just not be seen by the bear altogether.
Right. You'd want to avoid the bear.
Yeah.
There actually is a North American snake bite registry. From 2013 to 2015, they documented 256 rattlesnake bites, no deaths. But rattlesnake bites were associated with higher proportions of longer hospital stays, which makes sense.
Yeah.
Compared to non-rattlesnake species like copperheads and coral snakes. So you get bit by a rattlesnake, you're going to have to stay in the hospital a little longer. Now, although mortality is low, there's still significant mortality associated with rattlesnake toxicity. So it's basically like, respect these guys. Don't think, there's not that many people dying. Right? You want to respect them.
And I assume that all the people that did survive probably got the anti-venom treatment.
Anti-venom. Yeah. And that leads me to the next thing.
Perfect.
Is it anti-venom or anti-venin?
Oh, what?
Man, I thought anti-venom.
Haven't you heard?
The whole reason you brought up a word that I've never heard of before and I never would have used ever in my whole life makes me think that it's the second thing.
You've never heard anti-venin?
Anti-venin?
Have you ever heard that?
I don't think so.
So in my research, it did come up, anti-venin. And I'm like, okay, which one's the right one? So I looked into it and I found that the name anti-venin comes from the French word venin, I may be saying it wrong, maybe venin, meaning venom, which in turn was derived from the Latin venenum, meaning poison. Now, the reason this word existed is because early work in anti-venoms, there were 2 organizations in France that kind of led the way. So that's why this term is in a lot of the literature from the 20th century.
They got a snake problem over there? I
know
wonder
what?
why France.
That's a good question.
Yeah. Huh.
I'm not sure why.
Interesting.
So historically, that term anti-venin was predominant around the world. Its first published use was in 1895, but in 1981, the World Health Organization decided that the preferred terminology in English would be venom and antivenom, rather than venin and antivenin or venin.
I could have told you that. The fact that I've never heard the venin one.
And you know what? I honestly don't know how often I came across it before until I started researching this episode. And again, I've been researching this since like July, so I came across it a lot. So I didn't know how antivenom is made. I didn't know this previously, but
Homeopathy.
that's right.
They dilute it in an ocean's
They
worth
just
of
keep
water.
diluting it. They knock on it. So it's made by collecting venom from the relevant animal or milking it. And this isn't just for snakes. This is for, venom, other venomous animals.
Cows get milked.
Yeah. And injecting small diluted amounts of it into a domestic animal, like a horse, sheep, or a goat. Antibodies accumulate in their blood, and then they're extracted and centrifuged to separate the red blood cells. The resulting serum is purified often into a freeze-dried powder, although it can be in liquid form. And then a monovalent antivenom is specific for one toxin or one species, so monovalent, but there's also polyvalent ones effective against multiple. Here in North America, we read about crow fab antivenom. So the crow part of the name refers to Crotalidae. So again, that family of vipers, right? Or the pit vipers.
A subfamily, right?
Subfamily,
Yeah.
right. I couldn't find what the fab refers to. So it's
Fabulous.
not. Yeah, that's right. That's awesome. So it's not
I'll be
specific.
here all day.
Fabaceae, obviously the bean family.
The bean
Yeah.
That must be it.
Yeah.
So
We're onto something.
this
They do
antivenom,
look like bean pods a little bit.
it's not specific for timber rattlesnakes, but it's used to treat envenomations for the species, as well as copperheads, diamondbacks, and cottonmouths, because they're all related. Now, I didn't know this either. Because antivenom is derived from animal antibodies, people can often display an immediate hypersensitivity reaction. They can go into anaphylaxis from being
Like
treated.
if you're allergic to a horse or something. Oh, because it's another.
It's an animal.
Yeah, right.
Right.
Huh.
And this was a big stumbling block initially in the creation of antivenoms. And some people were arguing that maybe it's better just to try to work through the symptoms of the venom rather than give them the antivenom. But they've come a long way in dealing with it. And typically now they're prepared for those allergic reactions. So it could happen immediately. You can go into anaphylaxis, or you can have a delayed hypersensitivity, what they call serum sickness.
Huh.
Oh.
So if you ever have to take antivenom, just, ask about that. Hey, are you guys prepared in case I, my body freaks out? And I did find, in terms of vets in the U.S., more than 15,000 domesticated animals are bitten by snakes each year, just here in the U.S. So way more than people.
And they're a lot smaller
yeah.
too.
Me-
I would imagine that, and probably less likely to get treated because they can't communicate that they were just bitten.
And I don't think they know what they're dealing with.
Right.
actually.
Idiots.
Rattlesnakes
sorry.
account.
Quit
Rattlesnakes
insulting people's dogs, Steve. We love dogs here.
I did come across, I'll post this in the episode notes. There was one study that looked at what do they call those wiener dogs?
Dachshunds?
Dachshunds. A dachshund got bitten in the face, and researchers recorded, and this poor little dog, they were recording the little seizures he was going through.
God.
The fact that you called it a little seizure, like it was going to be something cute. Oh, when they have their little seizures, that's messed up.
It's
Bill,
kind of
all right?
sad to watch, but the dog
Yeah.
did survive. So
Good, good. Well,
Okay.
But they
All right.
wanted to document it because they said it's so rarely documented,
Yeah.
how venom does affect domesticated animals.
ma'am, do you mind if we, instead of treating your dog, record him?
No, they did treat it.
Is that what people do nowadays when something else is struggling? You just film it?
Ma'am, permission to film your dog.
We got to do this. We got to post this.
Yeah.
So rattlesnakes accounted for about 80% of those domesticated animal bites. Dogs are most commonly bitten on the front legs and head. Horses generally receive bites on the muzzle, so when they're going down to eat something. And cattle, they're often bitten on their tongues and muzzles.
Gross.
Because they're often sticking their tongues out, Symptoms include swelling, slight bleeding, sensitivity, shaking, and anxiety.
I would have some
Sounds
anxiety.
pretty anxiety-inducing. Yeah.
Crap. So let's talk about their conservation status. How are they doing? Now, we've talked a little bit about this in part 1. Steve's getting pelted by snow.
Yeah, it's starting to get a little windier.
All right, so do we want to move? Here, we're going to move over here.
Yeah.
We can kind of get into a sheltered spot over
I was
here.
enjoying watching Steve get pelted. That's pretty fun.
Yeah, when I made the first remark about a dog and I looked behind me, I was like, they could just kick me down this thing.
I wonder if any of these animals can learn to discern like a venomous snake, because I've heard that about the barred owls down south, because that was the number one prey that I would see barred owls eat are snakes, and I'm like, are they immune to the venom? What's up with that? And then I'd heard that they approach a venomous snake differently in how they attack it. They'll pin it behind the head, and if it's not a venomous snake, they'll just fly off with it.
Look into that.
Yeah, I do want to look into that.
Say, I know I've seen a video about a honey badger, and it didn't seem to care at all about getting bit
Don't
by
they eat something poisonous, honey badgers?
I think they do. I think they straight up eat venomous snakes.
Yeah.
I don't know. I'm sure that's not all they eat. In fact,
Exclusively.
In fact, the video I think I saw was more of a comedy video. It was the guy that like narrates over nature videos and adds like funny. Yeah.
Snoop Dogg?
I forgot
Those
about
are good.
I forgot about that. Yeah.
All right, so we already mentioned that bounties were offered for rattlesnakes, not just timbers, but all rattlesnakes in, I would think, almost every state in the Union. To give you an idea how common rattlesnakes were in certain areas, in Massachusetts in the 1600s, the timber rattlesnake population was widespread. There was one town, Westboro, that it was documented they paid 13 men 2 shillings per day to rid a local hill of snakes in 1680. The hill had so many rattlesnakes, it was named Boston Hill because the number of snakes killed rivaled the population of the young city of Boston. Notice I said Boston. That wasn't on purpose.
Done. It's better than the colonial accent earlier.
Oh yeah, we never commented on that.
You were so blown away.
Yeah. Starstruck.
Since that time, their habitat in Massachusetts has been reduced to just a few areas in the state, and it's illegal to harass, kill, collect, or possess them. But in 2021, I did come across one was filmed. A 5-foot timber rattlesnake was filmed on a trail in the Blue Hills Reservation, which was just a half-an-hour drive from Fenway Park in Boston. So
wow.
Yeah.
Wow.
So not far outside the city. The timber rattlesnake is listed as endangered in a number of Northeast states, including here in New York, as well as Ohio, Virginia, Indiana, and Illinois. Here in New York, timber rattlesnakes are extirpated at 26% of historically known dens, so 1 out of 4, and nearly extirpated in another 5. There was one study that suggested denning populations in New York have been reduced by 50 to 75% of their historical numbers. But as Daniel mentioned earlier, in Pennsylvania, they have the strongest timber rattlesnake population in the Northeast. I was wrong. There was over 2,000 sites recorded in the state.
Wow.
They're doing
Nice.
so well there that you can actually get a permit to collect 1 timber rattlesnake per year.
As a
funny.
pet.
Yes, as a pet. No, I don't think you can have that. The species is classified now kind of globally. Stepping back to look at the whole species, they are classified as least concern on the IUCN Red List, so the International Union for the Conservation of Nature. They were last assessed in 2007. Species are listed as such due to their wide distribution, presumed large population, range-wide, and because they're unlikely to be declining fast enough to qualify for listing as a more threatened category. So
That's
as a
interesting.
whole, I'm sorry.
I was just going to say in the status discussion in the DEC status assessment that you mentioned from 2013, it starts off with timber rattlesnake populations have declined range-wide from historic levels by perhaps 85 to 90%.
Oh, so even more.
Yeah, but that's range-wide. I think you mentioned New York.
Yeah. So that
so
was
it's range-wide.
That was a New York State assessment. They were talking range-wide.
Yes,
Yeah.
yes. So in the New York State assessment, they talk about certain conditions in Pennsylvania and other states as well.
Now remember, this Red List assessment, that was done in 2007. I
Okay.
mean, that's 15 years ago. Maybe they've declined so much in that time that maybe the next assessment that's done, they'll be upgraded. One thing that I noticed that I found interesting, research in 2013 suggests that timber rattlesnakes may be doing a huge favor in the areas where they are, doing a huge favor to us by eating rodents known to spread Lyme disease.
Yes.
But, as far as what's affecting them mostly, it's, as we already mentioned, habitat loss, persecution by humans, overcollection, for the pet trade. Also, snake fungal disease, SFD, it's often referred to. It's an infectious disorder that can lead to blisters, clouded eyes, and life-threatening skin lesions.
Oh, wow.
And I came across that is potentially exacerbated by climate change. If you have more wet springs upon when they emerge from their hibernaculums, then they're more susceptible to these fungal diseases that can kill them.
Sure.
And their populations may not be as strong too due to inbreeding. I don't know if you came across that. We talked about how they have some pretty strong fidelity to their hibernaculums, and then they'll usually stray a couple miles or so away from them. And back before their habitats are so fragmented, during the straying, they could intermingle with other rattlesnakes in different hibernaculums. But because their habitats are so fragmented now, they don't really have that opportunity as much, and they're intermingling with members that have already been in their own hibernaculum and causing inbreeding, which then just exacerbates everything else. Keeping it in the family.
I did come across that they do not like, as a species, that species in particular, do not like to cross open areas.
Yeah.
So when a forest is fragmented by a road or some opening, they're not going to cross it to reach another population. So along with what you said, there's just the populations aren't intermingling like they used to.
Yeah, and just for the audience, because one, we haven't put an episode out in a while, but so the danger of inbreeding is just, I think a good way to summarize it is like, let's say even if you have 1 million individuals, if all of those individuals are nearly genetically similar, like to each other, they're all like genetically the same. That means there's no variation within the population to adapt to any type of like environmental stresses or whatever. Yeah. So, because, and this is maybe a little bit of something that people don't understand, but evolution only acts on the standing variation. So it's not like, oh, bad things are happening, time to evolve, time to change things. That's not how it works. They work on what's already there. You can't just decide you're going to change. You have to have some variation within the population for evolution to act on, because the ones with certain traits are going to be the ones that survive better. But if every member in your population is the same, or
even almost the same,
because you're never going to be perfectly the same. But so if you're all nearly genetically identical, there's nothing for evolution to really to act on.
Yeah, it's bad.
So that's the reason that inbreeding is so problematic, or one of the reasons, I should say.
So one of the things I mentioned in part 1 was that, and this is a trigger warning for anyone out there that
who hates snakes. Sorry guys, but this is the time we're going to warn you.
For someone who is greatly upset by cruelty to animals, you may want to skip ahead a couple minutes. Yeah. I had no idea that in certain parts of the country, for decades now, they've done rattlesnake roundups, where people go out and collect as many rattlesnakes as they can. And historically, this was kind of seen as a way to get rid of these, quote, I'm doing air quotes here, dangerous animals. Mm-hmm. I know they are dangerous, but as we pointed out, not many people die every year. But they go out and kill the rattlesnakes that they gather historically. Now, over the decades, some rattlesnake roundups have turned into more of a educational event.
This is how you kill them.
No. Just to educate about rattlesnakes.
Yeah, teach a man to fish, you know what I mean? Yeah.
Some of the roundups, as we mentioned before, sometimes then release the rattlesnakes, but that's not always hugely successful in terms of the numbers that
didn't
survive.
You say early on in the episode, part 1, didn't you say that after these roundups only like 50% survive or something?
That was one study that looked at one particular roundup and release.
I see.
There's one roundup though, I'm going to call one out, in Sweetwater, Texas. As far as I can tell, they don't collect timber rattlesnakes because those are protected in Texas. They're threatened, but they go after other rattlesnakes. And here's a trigger warning, folks. Skip ahead. They collect these rattlesnakes, and then in front of the crowd, they have like people come up, kids including. They hang the rattlesnakes up, behead them, skin them, and then on the wall, everybody that does it puts a handprint in rattlesnake blood and writes their name next to it. I was like, I could not believe this is still happening in this day and age. And
Texas.
And the articles that I read about it, there'd be newspaper articles, not scientific articles, talking about how this is a town that doesn't have a lot of business, and that
are they eating the snakes?
There is eating of snakes.
I was gonna ask that.
They do the skins.
I mean, it sounds like what people do to deer almost a little bit, but
the skins are used to make things out of the skin. But they're saying, well, this is one of the major drivers of
their economy.
Because it does bring in like millions of dollars. but
Really?
I don't know.
That much money?
They said it's huge. They get tens of thousands of people coming into this thing. So,
Well,
but
don't
just-
people pay a lot for like snakeskin stuff? Or I've never
They-
seen a snakeskin thing,
imagine.
but I feel like I've heard of it.
But it just blew me away. I had no idea this was happening. So, startling.
Yeah.
All right, but
But you're a vegan.
yeah, I know. So, overall, it seems that timber rattlesnakes, their populations are declining. I'm interested to see, in the long run, in the next 5 or 10 years, if the IUCN does another assessment, are they still going to be least concerned, or are they going to be upgraded?
Yeah. Yeah, because according to the DEC status assessment, they're declining in almost every part of their range, except for places where they're already extirpated.
You can't decline in a place.
Decline anymore.
Yeah.
That's
They really put that in there?
They did. I know. That's why I wanted to mention that, because I was like, man, that's pretty funny that they put that there.
Right.
And then
they're
mention
they're alive except for the ones that are dead. We have to mention those.
Ones they're dead are still dead.
I think they think that we're really dumb. I don't know.
So
They're like, I'm going to make this one real digestible for the non-scientists.
I'm going to wrap up with circling back to what we started with, a little bit of U.S. history. So timber rattlesnakes were some of the first venomous reptiles that Europeans encountered here in North America. And it didn't take too long for them to emerge as political symbols. So in a 1751 article titled Rattlesnakes for Felons, Ben Franklin, he slammed the UK for sending convicted criminals over here to the 13 colonies. And to get even, he proposed shipping live rattlesnakes back to London.
Wait, was it the UK back then?
I don't know. That's a good question.
I thought that was an
No, it would
after.
just been Great Britain.
Maybe.
Yeah.
Come on, Steve. Rat-
It sounded
What are we
wrong.
now?
I
What are we
don't want to
now?
be spreading
right.
misinformation.
Push up your glasses. Rattlesnakes, he said, rattlesnakes seem the most suitable returns for the human serpents sent by our mother country. So he was joking somewhat, but Franklin grew to appreciate that Franklin grew to appreciate the timber rattlesnake and see it as a mascot of sorts for the emerging United States.
You know what? Hold on. I'm sorry. It's so funny because he uses it negatively first, right? And he's like, you know what? We are snakes. The colonies are kind of
That's
snakes.
self-awareness.
Yeah,
That's
yeah.
self-awareness.
It's like we
remember-
can laugh at ourselves, guys, right?
There was this existing myth that rattlesnakes had 13 rattles.
Yeah.
So they saw it as a link to the colonies, in that one rattle by itself didn't make noise, but the 13 together did. And they were so common. They were feared, right?
Yeah.
So it became a symbol for the U.S.
So Benjamin Franklin, he wanted to make the rattlesnake a symbol of the U.S. and the turkey a symbol of the U.S.
well, that was going to go on our seal,
I see.
right? But remember,
The
we talked
turkey
about
and the
that.
snake on the...
He didn't want
I'm sorry, because we did have the
he
bald
didn't
eagle episode.
actually
Yeah.
propose the turkey.
I see.
All
I
right?
see.
He talked about it, but he didn't propose it. So he wasn't alone. In 1776, a U.S. Navy commander-in-chief created a yellow flag bearing a rattler and the slogan, "Don't tread on me." So that was Christopher Gadsden, and that's why that flag is called the Gadsden flag.
Oh, I actually didn't know it was called the Gadsden flag.
And this distinctive and polarizing banner is still widely used 2 centuries later. Now, in researching this episode, I did come across some great variations on the Gadsden flag.
Oh boy.
So one of them was, if for all you Dune fanatics out there,
Oh, I like
they had the flag, and instead of the rattlesnake, they had a
a
sandworm,
worm, a sandworm. Yeah.
and it said, "Don't tread rhythmically."
That's so good.
That went right over my head.
Yeah.
That's okay. And then there's one that had like a kid's drawing of a snake, and it said, "Please no steppy." But my favorite one was, it just said, "Don't tread on me," and then instead of the snake, it had a Lego.
Oh yeah.
Can I say my favorite one?
Sure.
So the snake has a ball gag in its mouth.
I saw that
And
one.
it says tread on me.
Please tread on
Please
me.
tread on me.
Nice.
Yeah.
All right, so that's everything I have. Daniel, anything?
No, that's all I have too.
All right.
How many venomous reptiles are there? I was just thinking, because you said it's the first venomous reptile the settlers came across. How many other venomous reptiles are there?
Well, here in the Northeast.
9,761 exactly.
Yeah.
But what other common species do we talk about as being venomous reptiles?
Well, I mean, there's other venomous snakes.
Oh, he was
Right.
saying it was the first venomous species of snake.
Right.
I see.
Yeah.
I see.
Yep. But there are other venomous reptiles. Okay.
Name 10.
I can't.
You
All
asked
right.
too much of us,
I
Steve.
know.
All right, so that means it's time to do our wrap up. Daniel, take it away. First time.
First and foremost, we'd like to thank our growing list of Patreon supporters. So thank you to our new patrons, Ann B, Emily, Brant S, Sung, Zoe and Leah, Marcus M, Mootlin, and Kimberly B. We also like to give a special shout out each month to our top patrons, so stick around for the end of the episode to hear Field Guides listeners Julian share that list. And remember, if you'd like to be a part of the Field Guides and read our patron list in a future episode, email us at thefieldguides@gmail.com.
And we also had another new patron, some guy named Dan M.
Well, I was upset about that because I was a patron for a long time and then my debit card expired. So when I noticed that I wasn't on the list, I was like, what happened? And then I figured out why. So now I think I linked it to my bank account so that doesn't happen.
That's all right. I just thought it was funny going through the list because at that time I think you might have still been down south.
I think it was right after I came back.
Right after you came back, but we hadn't asked you yet to officially join. All right. So
is that why you asked me?
Yes, that's why. We also want to give a shout out to our research assistant, Jen B. She is a longtime listener, and she sent an email a while back asking if we would like some help. And she's local, so I was able to sit down, meet with her, find out that she's not crazy. And I was able to say, sure.
Wait, that's not what you said about her.
Good thing to do that with me. I wouldn't be here.
Jen did a lot of the initial legwork for this episode, so thank you, Jen, for doing that. And then there was one patron I left off the list, and that was Colin G. So he's another new patron. He's a friend of ours. You know him from Instagram, the photographer. You met him. So he's come on some of our hikes.
Okay.
Yeah.
Okay.
So he came on our oh no, you didn't come on our last hike.
No.
So, but shout out to Colin. Thanks you for becoming a patron. I also want to give a shout out to someone who left a comment on our website. It was on our Hellbender episode, and he just called himself, it could be a woman as well, Texas listener. Because you
got to be kidding me, man.
they
better not be from that one town in Texas.
Right, they're from Sweetwater, Texas.
Leave the rattlesnakes alone.
They gave a nice constructive bit of criticism.
Oh, good.
They're the ones that mentioned what we talked about before we turned on the mic, how you often talk much louder than I do.
Oh.
And he said while he's listening to us in the car, he's constantly having to adjust the volume. We see you, we know, and it is something we deal with on an episode-by-episode basis. All right, if you'd like to support the podcast, consider becoming a patron of our show at patreon.com. As a patron, you'll get access to a special patrons-only version of our episodes that includes Bill sharing the episode notes. Because of support from our listeners, we've been able to keep the show free and make cooler episodes like Insectapalooza, and one we'll be doing shortly where Daniel and I are going to be heading down to Florida and try not to get eaten by Florida Panthers.
And you'll know if that episode never comes out that they did get eaten by Florida Panthers.
Hopefully just one of us comes back to tell the tale, though.
Right. Or you guys can make a one-time donation through PayPal on our website. A big thank you to Jay Jean for his generous donation in June.
Yeah.
Oh, is that the Jay Jean we know?
Yep.
Yeah. And don't forget that we have Field Guides merch available through our website store at thefieldguidespodcast.com. Remember, if you can't financially support the podcast, you can help out by sharing it with friends and family and by subscribing and leaving us a review wherever you get your podcasts. It helps spread the word and allows us to reach a wider audience. So we'd like to thank our newest iTunes reviewers, Bobby Boy 278974, that's how I decided to read that one, and Michelle Bender.
Yeah.
So come enjoy our periodic podcasts on Facebook, Twitter, and...
Not periodic podcasts.
What does it say? Oh, posts. Come enjoy our periodic posts on Facebook, Twitter, and Instagram. And you can always email us your ideas for episode topics, criticisms, or your stories of personal encounters with the noodles, dangerous or otherwise. Bill wrote this. And you can send that to thefieldguides@gmail.com.
And remember to get those kids outside. Let them get muddy and dirty or snowy, and let them flip over rocks and logs. And if you don't have kids, remember to make time to get yourself outside as well.
And remember to make kids. That's what I thought you were going to say. And I was like, Bill, some people.
Folks, thanks for listening. We'll see you next time.
Yeah, see you next time.
Bye, everybody.
Hey, this is Julian from over in the upper Hudson Valley of New York. The Field Guides would like to gratefully acknowledge our top patrons: Charcuterie, Eric, Alyssa, Jesse, Adam, the Hebranks, Mary, Sung, Kimberly, Peter, Callie, Jessica, me, Orange Julian, Diane, we named the dog Indy, JJ Kathy, Dwayne, Jonathan A, Colin G, M. Tulin, Brant, Jonathan K, Matt E, Plants in My Pants, Sean M, Sophie, Connor, Measure and Principle, Fragaria papillonoidea, Outside Chronicles, Andrew C., Brandon, Quixote, Robert P., Max D., Jake, Melissa Marie in Dusty, Arizona, Kelly, Sarah, Helen, MD, Judy, Ben, Jane, DoodleDude82, Kazzies, Jeff S., Esther, John W., Mark V., Bethany, Rob M., and Hannah. Thank you for making the field guides possible.
All right, we ready? Oh, hang on. I think I messed up here.
You piece of
I know.